Hello, grade 11 mathematicians, mindsetters. This is another great lesson for you. My name is Abraham, and I'm not alone. I'm with Dina. How are you, Dina?
Hello, Abraham. Very well, thank you. I'm hoping everybody's well out there because we're about to explode with another grade 11 lesson.
And what is it all about?
We've been working on functions, so this is the fourth session on functions, and we'll just be working with sketch graphs and doing some interpretations as opposed to just sketching them from scratch. So it really is interpreting functions today.
All right, I'd like you to keep that energy. So go take your position and let's
Good
learn
stuff.
more. Right, mindsetters, I've got some great news for you. Firstly, are you one of the next Future Stars? Well, Future Stars competition inspires young people like you to believe in themselves and also the power that education has in helping them achieve their dreams. If you're one of them, simply log on to sastudy.co.za and enter for the competition because there are so many great prizes to be won. Already there are also other mindsetters who've entered for the competition. All you need to do now is to get your friends also to vote for you. But other than that, this great show is proudly sponsored by Macmillan. So we're going to learn more. As I say to you, if you want to join me, go over Facebook too, facebook.com/learnextra. You can also tweet me, follow me, and I'll follow back, Tim follow back on @learnextra. Lastly, log on to our website for your notes on today's session on learnextra.co.za/live. For now, Dina, take it away.
Well, everybody, I did mention earlier that we're going to be looking at functions and interpretation of those functions. So let's have a look at what our lesson description is all about this afternoon. Firstly, I know that you've worked with domain and range for about 2 years, since grade 10, but we're going to define that again. What is domain? What is range? What is an asymptote? What is an increasing and decreasing function? So those are the 4 words that often creep up in functions, and we really must know what they mean, otherwise we are unable to cope with the demand of the function section. We're also going to apply these definitions, domain, range, asymptotes, increasing and decreasing functions, to the 3 worked examples that I'm going to do this afternoon with you. And then we are going to deduce from the graph that's been sketched, we're going to deduce what intercepts we have, what points of intersection there might be, and we're going to work with the lengths of lines from those sketch graphs as well. Lengths of lines that we're going to look at would be some vertical lengths, some horizontal lengths, and just generally just some interpretation that we can do from the graphs. So looking at the definitions, as I said, we've worked with this before, but just to recap, the domain, so if we look at the domain, is a set of all x values which a function can have. So if we have a set of values where x belongs to, then each of these in here is going to map onto the range. So every value that you have in the x set is going to map onto the y. That one's going to map there, that one's going to map there, etc. Each one is going to have a partner. The mapping is basically the partner that you get from the x values. So this set that you apply your function on is called the domain, and the set of resulting values is what we call the range. And we often need to apply that definition. And if you just remember D and R alphabetically, D comes before R, and if you look at X and Y, X comes before Y as well. So domain goes with X, so the domain is not the set of Ys, and range is not the set of X's. So domain are your X values, range are your Y values, and the Y values are coming from a set of X's that you're allowed to have in that function. Then your asymptote, any X or Y values that don't exist in the domain or the range, when we represent these values graphically, we recognize these values as the asymptotes. So something like y equals 1 over x. We can have every single x value in our domain. So in our domain, we have the set of all real numbers. However, there is one x value that is not allowed. It's 0 because 1 over 0 is undefined. So when you are sketching that x equals 0, that would be called a vertical asymptote. And any value in domain or range that's drawn graphically is understood to be your asymptote. Okay, then what about an increasing and decreasing function? How do we define increasing and how do we define decreasing? Increasing function is a function where the y values increase as the x values get larger. So any function is defined by what happens as the x value is getting larger. So in that case, if I plot an x to y, or I map x to y, and I'm getting, as x getting bigger, my y is getting bigger, my y is getting bigger, my y is getting bigger, then we call this trend an increasing trend or an increasing function. On the other hand, if we have, let's do it blue, if we have a decreasing function, if the y values decrease as my x's are getting larger, so as I go x getting bigger, x getting bigger, x getting bigger, but my y values have a trend where they are decreasing, then that is known as a decreasing function. So notice that we have something that's that doesn't change, something that's constant. That's as x gets larger. So we're not defining it as x gets smaller or larger. We're always defining it as x gets larger, so that this pattern is seen as my x values increase. If y also gets bigger, it increases. If y gets smaller, it decreases. And it's important to understand that we're going to define functions in terms of whether they increase or decrease. And it's got nothing to do with the x values, but everything to do with what's happening to your y values. So it's the y value that determine whether it's an increasing or decreasing function. Right, we're going to be asked some questions now on those definitions. And I've adapted the questions from the Macmillan book, Clever Keeping Math Simple. And the one question says that the given sketch shows the graphs of f of x is 8 over x minus 4 and g of x equals negative 2x plus 6. Now, I know that the functions have been labeled, but if we weren't looking at the picture, how do we talk about this function g? Okay, g is this linear graph, and we know it's linear because the power is 1. So my straight line g therefore has a nature based on whether it's increasing and decreasing. And what would you say the nature of that function is? Would you say it's increasing or decreasing? Let's have a look at what's happening to the x values. As x gets larger, here's my y value. What happens to the y value? What happens to the y value? It's decreasing. So a decreasing linear function will always have a negative gradient, and an increasing linear function will always have a positive gradient. So this is actually a decreasing function. And if the function f is what kind of a function? It is a hyperbola. And can you see, again, this denominator x implies that if there's an x in the denominator, there is going to be a restriction on a domain. So what would the domain be? It would be every real number except 0. And hence, this line over here would be an asymptote. Also, this horizontal is an asymptote because it can be anything but 4, because if y is 4, then I'm going to get an x of 1, or an x of 0, which I can't have. So there is an asymptote over here of y equals negative 4. Now notice that I haven't got directly to the questions. We've done some analysis of the functions, what they look like, what their trends are, in terms of the definitions for our scope this afternoon, which is what is the domain, what is the range, what are the asymptotes, and is it increasing or decreasing? So we first did that analysis to the straight line. It's a decreasing function. The domain and range for a linear is not restricted, but for the hyperbola, it will be restricted. It has an asymptote. And the moment a function has an asymptote, its domain and its range will be restricted by that asymptote. So there is a connection between the asymptotes and the domain and the range. Okay, and once you've got a feel for what the functions are doing, how those values are placed on the graph, you then begin to answer the question. So don't jump in until you've done that broad analysis of the context that you are working in. Okay. So we'd like to know what are, well, that's exactly the first question. Give the equations of the asymptotes. Okay, those values in the domain and range that are not valid. Calculate the coordinates of A. It's an x-intercept. What do we do when we find the x-intercept? The x-intercept is found where the graph cuts the y-axis. And at that point, that means we are substituting y equals 0. So again, we're still doing an analysis. Determine the coordinates of B, the x-intercept. Determine the coordinates of B, the x-intercept of G. So we've got another intercept. So we have an x-intercept again. So we want to substitute. We want to substitute x equals 0. Then we want to give, here we go again, we are going to apply the domain and the range of one of the functions. And then here's something interesting. For which values of x is g of x less than 0? We want to work on that as well. Determining when are functions negative, when are functions positive, when are functions bigger than others, and what do we look at, what do we focus on? I find often students battle with understanding how to actually go and find that on the graph, what they're being asked, what they're being given, and how they can put the two together. Right, and then we've got some coordinate work. Okay, so as you can see, those asymptotes, domain, range, intercepts, whether a function is positive or negative, all those always being asked, and so we need to understand what they mean. Right, so let's go back to the function. What are the asymptotes of the hyperbola? Well, we said that x can't be 0. So therefore, this vertical line here, the vertical asymptote, would actually be the line x equals 0. And it's always the x value of that denominator. So if that denominator had a constant, it would be the value that would make the whole denominator 0. So the asymptote would be x equals 0. That would be the first one. Then the y asymptote is this line here, which is always the constant of that function. So in this case, my y equals minus 4 is going to be my asymptote. And that's my horizontal asymptote. So this function cannot have the y value y equals minus 4. And it becomes a horizontal asymptote. So we've got a vertical and a horizontal asymptote. Then we want to calculate the coordinates of A. And the coordinates of A are where the hyperbola is crossing the x-axis. So we can go down and say that my function f is the function 8 over x minus 4. And for the x-intercept, we're going to substitute y equals 0. Therefore, 8 over x minus 4 would be 0. 8 over x is 4. And so we get an x of 2. So my x-intercept is 2. So we can go up, and we can write on here that this is actually a value of 2. Then we would like to know b, the x-intercept of the straight line, and the straight line is minus 2x plus 6. So the straight line is minus 2x plus 6. We're going to remember always to say what you're doing. I'm going to substitute y equals 0 for my x-intercept. Therefore, minus 2x plus 6 is 0, which gives me minus 2x equals minus 6. So x is 3. So I go back up to the graph. As you're finding things, it's like a crossword puzzle, you're putting them on. So it makes sense that 3 is to the right of 2, because if I had anything like a minus 3, for example, then I know something's wrong because I'm on the right-hand side, but I'm getting a negative value. Okay. Then we have the domain and range of f, and f, remember, is your hyperbola. So the way we denote this is by saying the domain, and then you just put a little subscript f to indicate that I'm talking about f. And the domain is every single real number except the element 0. So we indicate it by curly brackets. And the range of f is all the real numbers except that y value that the function can't have, which is -4. So little subscripts to indicate which functions you're working with. Without the asymptotes, you wouldn't be able to find that. Then for which values of x is g of x negative? Okay. Now, let's see. This portion here is what we are given. We are given that g of x is negative. So let's go up to the graph and see. G of x is my straight line, and they are saying for which values of x is g of x negative. Now, you must remember that for every function, I like to always look at those bubble diagrams and say every function's got an infinite number of x values, and every x value maps onto a y value. When they're asking you to find x, what they're saying is which x value will make the function values negative. So try and read that in a different way. Don't just read it as it stands there, g of x is less than or equal to 0. Try and read it as g of x is negative, but interpret that. What does it mean? It means when the y values are negative, when they are negative, go and find the partner that makes those values negative. Now, I could be talking about this very algebraically, very theoretically, and not having any diagram to back me up. But in this case, we've actually got a diagram that actually has mapped those values for us. So let's go and have a look. Where is that mapping giving us negative y values? So I go to my graph, and where am I getting this means that the y of g is negative. Where am I getting negative values? Well, the boundary is always going to be the x-axis, because that's where it's 0. Anything above the x-axis is positive. Anything below the x-axis would be a negative y value. And then color in what they've given you. They've actually given you the mapping is all the y values are negative. Once you've sketched the given negative values, your next question is, well, give me the x values for which that is happening. So very often people don't understand what the question's meaning. The question is saying, here's a mapping, all your y values are negative, go and find the partners, the abscissa, that will make that negative. So if we were looking at those bubble diagrams that I did earlier, every x value maps onto a y, every x maps onto a y, every x maps onto a y. This question is saying, go and find all the negatives and then tell me for which x's does it happen. But this mapping, all these pairs of numbers, have actually been plotted. And so from the plotting, we are able to say that at this value, at 3, my y value is 0. But if I go to the right of 3, if I'm at 4, for example, my y value is negative. If I'm at 5, my y value is negative. If I'm at 6, my y value is negative. So this is what I sketch. This is what I color in. Color it in on the graph, because that is my given. So color the given. Once you've colored the given, you then say, okay, that's what they've given me, the y values. Read the x's. The question is to find x. So I must find x. And isn't that the usual maths question anyway? Find x. So that's happening. So I'm starting at 3 and I'm going all the way to infinity. So my x values would therefore be x must be greater than or equal to 3. That will make that statement true. That will make the given statement true. Okay, and then let's look at the coordinates of C and D, the points of intersection, because we spoke earlier that that was part of our plan for this afternoon, to find the points of intersection of F and G. How do we find points of intersection algebraically? Okay, points of intersection are points where the functions are equal. So they are found when f of x is equal to g of x. So algebraically what's going to happen is we're going to have an equation of f equal to the equation of g. And we now just solve. We've got a denominator. I like to get rid of the denominator by multiplying by x on both sides. So we get 8 minus 4x equals minus 2x squared plus 6x. Now we've got a quadratic equation, so we can solve by collecting all our terms together. So it's minus 10x plus 8 equals 0. I notice that there's a common factor, so I'm going to make math as much easier. So I'm going to divide by 2. So we're left with x squared minus 5x plus 4 equals 0. We can now factorize, so it's minus 5. Let's undo that. X minus 4 times x minus 1 is equal to 0. So we've got minus 5x plus 4. So we get an x value of 4, or we get an x value of 1. Let's go back to the picture and see, are we happy? Does it make sense? 4 and 1. Here's the first point of it. 4 makes sense. It's to the right of 3. And 1 makes sense. It's to the left of 2. So that's great. How would we find the corresponding y value at D and at C? We can substitute either into the yellow, or we can substitute into the hyperbola, whatever is easiest for you. If we substitute into the straight line, we get 6 minus 8 is negative 2. That makes sense because we've got a negative y value. And over here, if it's 1, 6 minus 2 is 4. So the y value is 4. And it makes sense. It's just a little bit below 6, which is that y-intercept. So you're always validating what you are doing algebraically versus graphically.
Right, I have some few questions that I'll give you after the break. Hope you'll be ready. Mindsetters, keep those questions coming, and also comments over our Facebook page. We'll check you out right after the break. Matriculants, welcome back. I hope you're still learning a lot. As I'm hearing on the page that so many mindsetters are enjoying the show, there's also a phrase at top was saying, what a challenging show, guys. But guess what? Your positive attitude will determine the altitude of this show. But I have two questions for you, Dina. One is from Ayanda Trevor saying, is there a simple way of finding out the coordinates using a calculator?
A calculator can do many things. However, a calculator will not be able to assist you in putting that on paper for your examination. So certainly you can use the calculator as a tool to support the thinking, the arithmetic, all those kind of things. But ultimately, when you calculate the coordinates of a point of intersection, the examiner needs to see your thinking, needs to see every step of your calculation, otherwise you don't get any marks. So even if the calculator is able to do, there are calculators out there that are able to solve simultaneous equations, the examiner still needs to see your working out. So my answer to that is no.
All right, and I think at times they'll tell you use a calculator, and times they'll say don't use a calculator.
That's right, and you've got to really be attending to the instruction. If it says no calculator, obviously you have to use some kind of method of showing calculations. It's very, very important to show your calculations. 3, 4, 5 marks. If you just write down the answer, you're going to get penalized because we can't see your working. So always show your working.
All right, one last question from Fraser Tap was saying, for coordinates C and D, are we using simultaneous?
Absolutely. The coordinates we've just done in the previous example were the coordinates of 2 points where both graphs are the same x and y value at the same time. And graphically, if x and y are the same, then algebraically you're going to be solving 2 equations at the same time. And solving 2 equations at the same time, we have one word for that, simultaneous equations.
All right, let's move on.
Thank you. Right, the next question we have is, again, from Macmillan's book. This time round, we've been given one function, f of x is 2x squared minus 12x, and the other function has got some missing information. Again, we'll do some analysis. What kind of function is this? Quadratic, because the highest power is 2, and the highest power is 1, so therefore that's a linear. The 2 graphs intersect at O and C, and D is the turning point of the parabola. So we've got a turning point, which we haven't discussed before, and we've got some parallel lines, but we've also got a point of intersection. So again, we're working with a point of intersection. So we've got F is my parabola, and we've got this linear. And can you look and see what are the unique features? What is particularly unique about this parabola? Okay, remember, when you define the nature of a function, you look to see whether it's increasing or decreasing. Well, firstly, the parabola, as x gets larger, I am decreasing. then I'm turning, and then I'm increasing. So this parabola is what we call has a minimum turning point, because as my y gets smaller and smaller, it's not dipping to infinity small. It's actually reaching a minimum, and then it's turning. So we also define functions by the kind of turning points they have. We would talk about this as a function, a quadratic function with a minimum. Then we know that it must be decreasing, and it increases after that turning point, after that minimum turning point. So we define a parabola as a minimum turning point function. So first of all, it's important to understand that it decreases to the turning point, and then it increases. So that's one characteristic of this parabola. What else? If the parabola does have a minimum, then it means that it must have a restricted range. The range will start at the minimum, and it will increase all the way to infinity. But it doesn't have any asymptotes. Unlike the hyperbola that's got asymptotes, the parabola does not have an asymptote. It has a turning point, and the moment it's got a turning point, it also has what we call this very special line over here, which is what? Its axis of symmetry. Now, all that analysis you should be doing for yourself. It's almost like a little comprehension. You should be understanding for yourself, describing these functions as you see them. You cannot be looking at something and you just go blank, because otherwise you cannot answer the questions. Engage with what you see. What's it doing? Is it growing, or is it dipping? Is it increasing, or is it decreasing? So we have decreasing, minimum, increasing. Okay, something else unique about this parabola is that it crosses at the origin. So its x-intercept and its y-intercept is the origin, which automatically means that I've actually got some information that's unique, because this axis of symmetry actually bisects this distance at those x-intercepts from the origin all the way through to B. So those kind of things are very important to observe, so we don't get stuck later on with the minefield of algebra that we've got to get to. All right, so let's look at what kind of questions we need to be looking at. Firstly, the coordinates of B. Okay, what is B? We've already said B is a x-intercept. And what happens at B is that this function, 2x squared minus 12x, will be equal to 0. So I'm just going to work on the side here. We have that 2x squared minus 12x equals 0. And while we're working with that, just another comment. If it does have a minimum, the parabola does have a minimum turning point, then your coefficient of x squared is always going to be positive. That indicates that it will have a minimum. So those discussions that you're doing around the nature of the function always help to confirm what's happening algebraically as well. And if that's 0, then we take out 2x, and we're left with x minus 6 equals 0, which gives us x equals 0 or x equals 6. So I have that this value here at B is 6, which means my coordinates are 6, 0. Just a reminder, if the question says coordinates, please don't just write one of them. You will be penalized. Coordinates imply both abscissa and ordinate, a pair of values to answer that question fully. Right, then we have the coordinates of D. What is D? We've already said D is the turning point. And how would we find the turning point? Well, we know that the axis of symmetry will bisect the distance between the two x-intercepts. So if that's 6, then we know that we've got 3 on either side. So this axis of symmetry is x equals 3. Okay, so that's one way of working out the turning point. So the turning point is going to be the point 3, and then I can work out what my y value is by substituting back into the original. So I've got 9 2s are 18 minus 36. So that gives me y value of minus 18. So that would be my turning point. And if I go down here, for those of you who may be saying, but we've got a formula for the turning point. Yes, we do. It's good to have two ways of confirming your calculations, because there's no easier way to develop your confidence than to have a multiple strategies of working something out and seeing how they merge and how they come together and how they give you the same answer. It's wonderful. So if we were to use the formula for the turning point, then we'd have x of the turning point would be your minus b, which would be your 12 over your 2a, which is 2. So we've got minus 12. Let's just go back up here. What was the function? Yeah, minus 12. So it's actually plus 12 because it's minus b. So it's 12 divided by 4, which gives you 3. So that would be your formula. There's also a formula for the y value, but we really don't need that because you can take that x value and substitute directly into your function. Okay, so that's the turning point. The coordinates of C if CF is 10 units. Now, this is very, very interesting. They are telling us that this distance from C to F is 10 units. Can you tell me what the coordinates of C are? If this vertical distance is 10 units, can you tell me what the coordinates are? Well, we'd like to work out what the x of C is. We don't know what that is. But vertical distances imply that we know the y value. So I know that the y value here is 10. Do you agree with me? Is that 10? Well, we're going below the x-axis. Any coordinate below the x-axis is going to be negative. So distance is 10, but coordinate is minus 10. And this is very important, grade 11s, that you understand that sometimes given information requires some interpretation. So today's lesson is all about interpreting what we are seeing. And so my y value is negative 10, which means I would like to go and find out what is the x value at C, which is going to be the same as the x value at F. Now, this orange function I have, but this white function I don't have. So I've only got one option, and that is to substitute into my parabola, which is, if we just go up there, 2x squared minus 12x. So what we're saying is happening over here is that 2x squared minus 12x is going to equal to negative 10. Now notice, if we did not make that interpretation from distance to coordinates, we would be saying this is equal to 10, and the whole thing would collapse because our algebra would not be right. So it's important to just pay attention that distances in this Cartesian plane are all positive. But if we are on different quadrants, we must look at the coordinates very carefully and establish, is it positive, is it negative? So I'm going to divide by 2, so I get x squared minus 6x plus 5 equals 0. And I can factorize this as x minus 5, x minus 1 equals 0. So x is 5, or x equals 1. So what do you think is happening at C? Is x equal to 1, or is x equals to 5? And how would you argue that? Well, I think definitely it's got to be bigger than 3, because we've already worked out that this x value here is 3. So it cannot be 1. What we're saying is that around the axis of symmetry, every point on the parabola is symmetrical. So there's going to be another point on this side that's also going to have a distance of 10, and that point is a point 1. But at C, it definitely is 5. Let's just undo that, and let's just go and make it green. So we need to just make that green. There we go. So that's 5, negative 10. Okay, so given the distance, make sure you interpret into the quadrants with the correct sign. What are the values of A and Q, and what are A and Q? A and Q are the gradient and the y-intercept. Where is this white line intersecting? It's going through the origin. So therefore, I know that my constant is 0, so my y is going to equal to ax only. So my q is 0. And what is a? A is my gradient. So I've got this is 5, negative 10. So I'm going up 10 across 5. So this function here is the function y equals negative 2x. You see how important it was to analyze and to see that going through the origin just means that my constant is 0. And my gradient, decreasing function, as x gets larger, y gets smaller, decreasing function always has a negative gradient. Right, so I think we will finish off with some
All right,
questions.
Dina, before you move to that, I
Yes,
have
have we got some
minds-
questions?
Yes, one, it's just two mindsetters being lost.
Yes.
Saying, can you please repeat the explanation for G?
For
For
G,
G on the previous.
previous slide. Let's
Yes.
just go back there. We'll do that with pleasure. G is a straight line, and the straight line is going through the origin. So any straight line through the origin means y equals ax plus 0. Okay? A is the gradient. So the gradient is the change in y over change in x. And if I take this point and that point on my line as reference, then my change in y would be 10, and my change in x would be 5, so my gradient is -2. So I got it from my change in y over change in x as my vertical over horizontal in order to get my gradient. You could also substitute the points, -10, -0, 5, -0, divide by y over x. The change in y over change in x, you can do it in different ways. But the idea is that it's a gradient that you're looking for. And therefore, y equals -2x, because plus 0, I don't have to fill in.
Well said on that
Okay.
one.
Okay, can we carry on?
Yes, please.
Cool. Right, then the real one that I want to get to, length, the values of x for which, ready, yes, okay. Okay, I really want to get to these. These are very easy to answer, very easy marks to get, but a lot of children will often go into an algebraic jungle and get lost and get no marks. So let's see how to get these easy marks by looking and just doing it. Firstly, it's to determine the values of x for which f of x is smaller than or equal to g of x. And how would we find that out? How do we determine? Okay, remember what I taught you earlier, which is to say, this means that I am given, okay, I am given that y of f must be smaller than or equal to y of g. So let's go to the graph and find out where does that happen. Okay, so there's g and there's f, and we have found that this point over here is the point 5, -10. Okay, and I think that's as much information as we need. Okay, so what I would like you to do is to take a piece of paper and to just anywhere on the left to say, what is happening to my y of f over here? Y of f is bigger than y of g, because at a specific x value here, my parabola is larger than my straight line. And can you see, if I move this piece of paper, I'm actually getting a shorter and shorter distance until they become the same. So we really have that at the point of intersection, the values are the same. But if I move over to the right, then my y of the straight line is bigger. And that relationship stays the same until they hit again the point of intersection. And when I go across the point of intersection, my parabola is again larger than my straight line. Excuse me. Okay, so my f will be smaller than my g between these two x values. That's where my parabola is smaller than my straight line. And if you put a vertical line anywhere, you'll see that my straight line is actually bigger than my parabola. So to answer that question, if you're given the y, you have to give an answer in x. Where is f smaller than g? It's smaller between 5 and 0. I'm going to get that relationship to be true. Then this one, remember how to read it. Where is y of f positive? Where do you read positive y values? Where do you find them? Where do you find positive y values? Above the x-axis. So let's go and mark where is f positive. Where is f positive? It's positive there and positive there, which means it's for all these values that way and for all the values this way. Anything above the x-axis, that has been given. Your job is to find for which x value does that happen. It happens for bigger than, I think we got this as 6, bigger than 6 and smaller than 0. So for this side, x is bigger than 6, and this side, x is smaller than 0. And I think just check whether it includes the 0 or it excludes the 0. Those decisions you make right at the end, whether you want to include or to exclude. And then we'll leave it at that.
All right. Let's take some quick commercial break because I see also on the page, grade 11s are so pumped up, and we also have some grade 12s. Guys, thank you for tuning in, and thank you for being on the page, helping one another also. We'll see you right after the break. Welcome back, pre-matriculants. Hope you're still learning a lot because we are still pumped up with questions and also giving you the notes about functions, learning a lot. And remember, as Dina said, that this is just a build-up, guys. If you're doing grade 11 now, asking about grade 8, go back to your grade 10 notes because that's where you'll find the real definitions. But otherwise, Dina, take it away.
Thank you, Mindsetters. You're asking a lot of questions that need a lot more detail, and you are helping each other, which is great to see. And I'm going to go through one last example in terms of increasing, decreasing, domain and range, and all those good mathematical things. But before I do that, let's just go back to the previous question and work out where is the one function multiplied by the other one, positive, something we haven't seen before yet. Let's go back there. It was number 6, I think. There we go. Okay, and it was this question, right here. How do we read that? Just ignore those little rectangles, but what that's really saying is, where is f of x multiplied by g of x negative? Okay, and I find that people battle to understand how to read this. What is it saying to me? And basically what it's saying is, okay, remember this is always a given, okay? So y of f multiplied by y of g is negative. Okay, so that's what we're given. So now we need to go back to the function. And remember, I held that piece of paper. I want you to hold that piece of paper as well. And let's take one x value, 1, and decide. If you take the y of the parabola and you multiply it by the y of the straight line, what do you get? A positive times a positive is a positive. So that's what it's saying to you. It's saying if you take one specific x value and the product is negative, where is that happening? But we're now just examining for every single x value so we can get a panoramic view of what is happening. So for this value, I'm getting that it's that positive times that positive. We don't have to know what the value is. We just need to know its sign. Where does it change? It changes over here because now we have a negative y multiplied by a negative y, and that product is positive. So that stays the same. Where do you think it's going to change? When one of the graphs crosses the axis, because then I'm getting a positive instead of a negative. So if I go across the axis here, you just keep going. Negative times a negative, negative times a negative, negative times a negative. They're all negatives. But the moment you go beyond 6, you now have a positive y, and you've got a negative y down here of your straight line. So we could actually rewrite this question over here and say that what we are given, okay, in sort of our own language that we can understand, is that the y of your parabola multiplied by your y of your straight line is negative. So we want a negative product, which means we're actually going to the y values of the graph. We're multiplying them together, and we're seeing where is the product negative. Now, if we go back to the graph, we'll see, hang on, these values here are both positive, so that's going to give me a positive product. These values are both negative, so they're going to give me a negative product. The only time I'm going to change anything is when the graph crosses the x-axis, because then I'm changing its nature, I'm changing its sign. So there I have a positive multiplied by a negative, and I get a negative. The question is, you found where it's happening. Question is, what is happening to x. For what x values does that happen? That's what you're giving as an answer. And where does that happen? After 6. So at 6 and after, at 7, for example, the y value here is going to be positive, the y value here is going to be negative. That's all that's happening. And so the product will be negative. Okay, does that help to answer those questions? You're going to get a lot of these questions in TREG. You're going to get a lot of these questions next year in grade 12 when you're doing cubic graphs, and they're going to ask you for when is it positive and when is it negative. And I want you to use some tools to help you. Use a piece of paper to guide you what is happening with those y values so that you can see them. You don't have to go and calculate them. You can just see where they are on that picture. Okay, so let's do one last little diagram of interpretation. Today is all about interpretation. We are given this orange function g, we're given that straight line, the white straight line, and let me ask you, what kind of function is the parabola? And what kind of function is the straight line? Is it increasing, is it decreasing, and what kind of function is the parabola? Well, the straight line has got a positive gradient, and any lines that have positive grade, it's almost like an airplane taking off into the sky. That is an increasing function. It's increasing in height almost, if you look at the plane analogy. So we've got as x gets bigger, y gets bigger. What about the parabola? As x gets bigger, y gets bigger, and then what happens? As x gets bigger, y gets smaller. So the parabola is increasing up to the turning point, and then it decreases. When a parabola does that, we talk about a maximum value, a maximum turning point parabola, because it's going up, and then it reaches the highest point it can be, and then it comes down. So your parabola has got that increasing and decreasing. So it's got both values, and then it's got what we call a turning point. Okay, so it's got a turning point. The question I'm really interested in is, for which values of x is g increasing? So where would the function be increasing? Where would this function be increasing? Well, it's increasing from here all the way to c, which is your turning point. So we would say that the function increases, and we can write it like this. G increases for x smaller than or equal to 5. Because it's decreasing to the left of 5, it just keeps it just keeps increasing. Well, what was the question actually? Yeah, for which value is x increasing? So it increases for anything smaller than 5, the function is increasing. And for which values of x is g of x positive? When is it positive? Where do we find y values that are positive? So that means y of g is positive. Remember to translate. Without translating, you go nowhere. So y of g is positive. Where is that happening? Where will we find positive values? Excellent, above the x-axis. So I'm finding them over there. That's where it's positive. Anything above the x-axis is positive. So we'll be finding that between 4 and 6. So this is between 4 and 6. And I'm not including 4 and I'm not including 6 because I want to know when is it strictly positive, not when is it equal to 0. Right, and then that's it. We'll leave it there.
Right.
Thank you
very much, Dina. On that short note, we just want to say thank you very much to all the pre-matriculants that have watched the show. And a big thank you to our sponsor, Macmillan, for promptly giving us content for the show, and also those notes that you'll be downloading or that you have downloaded already on our page. But from me and Dina, we just want to say thank you very much, guys. See you some other time. Cheers.